Hello everyone, today we're going to be talking about lesson 2 of electrochemistry, oxidation and reduction reactions. This should be a very brief lesson, especially if you watched the previous one. So to recognize a redox reaction, you simply need to identify whether the oxidation numbers have changed. And if they have changed, then we can start to do some interesting things with them, like measuring how many electrons have actually changed atoms. So let's look at this magnesium oxide mixed with magnesium oxide production from magnesium and oxygen. If this was in a classroom, we would probably burn some magnesium. You see a nice bright light, but we're not there right now. So magnesium is a metal, and we know that metals always have an oxidation state of 0 if they're just by themselves in their normal form. Also, oxygen as O2 is also in its elemental form, so it also has an oxidation state of 0. Now that they're in combination, we go to the next set of rules that magnesium is an alkaline earth metal, and so whenever it's in a compound, we're going to assume that it has a +2. And oxygen, being oxygen, if it's not in a peroxide, is also going to have a -2 for its oxidation state. So now that we know the oxidation states, we can see that magnesium goes from 0 and it changes into magnesium to a magnesium +2. Oxygen, on the other hand, goes from oxygen 0 and it changes into oxygen, and it is a -2. And so in this case, oxygen has been reduced and magnesium has been oxidized. Okay, so let's look at the next reaction. Is sulfate plus water forming H2SO3, is that a redox reaction? Let's investigate. We're going to look at the oxidation state for a sulfate, or SO2, sulfur dioxide. We assume that oxygen has a -2. There are 2 of them, so that gives us a total of -4. The compound has a 0 value, so sulfur must be +4. So let's put a +4 on top. We have water, H2O. Water starts at a -2, and hydrogen starts at a +1. And then the products here, H2SO3, hydrogen always has a +1, oxygen always has a -2, so let's just check the sulfur. We have 2 hydrogens, so that's a total of +2. We have 3 oxygens, so that's a total of -6. So what does sulfur have to be in order for this to add up to 0? Well, sulfur has to be +4. And so we can see that the sulfur went from +4 to +4. This is not redox, or no redox. I like no better. Let's check out the next one. Here we have a copper, which is always 0 because it's a metal all by itself. We have 2 silver nitrates. Okay, we'll have to take a look at that in a second. So let's go look at silver nitrate. We know that the nitrate compound altogether is a -1, and silver is a +1 when we treat it as a dissolved complex. So we can actually, we have it written here as aqueous. We know from our solubility rules that we can actually split these up a little bit. Let's put a plus, let's put aqueous over here, let's put a minus. This will make it a little easier to deal with. So silver is +1, so we can just write +1 on top. We have a nitrate here, which we have to figure out. So nitrate, we have -2 for oxygen is the assumed, -2 times 3, that gives us a total of -6, but this time the ion adds up to -1, so the nitrogen must be +5, which is a pretty common state for nitrogen. All right, then we get over to the other side of our chemical reaction, and I think I'm going to shift everything over to the right here, to the left. So let's go back to that blue color. So we have a copper and NO3, 2, and this is aqueous. So let's do the same trick that we just did. We're going to split this up It doesn't matter. We're just trying to determine that if this is aqueous or not. So if this is a minus, and we have 2 of them, then the copper must be 2 plus. That's a true charge on this aqueous copper. Aqueous means it's dissolved. That means that that salt will not stick together. And then we have 2 silvers. The silver now is going to be 0 because it's a metal. And the copper now has a +2 oxidation state. Notice how I moved the symbol to the other side because we're indicating oxidation states. And then these are the same nitrates we saw before, so we don't have to do the work again. We can just say +5, -2. And here we see that copper goes from 0 to copper +2, and the silver goes from +1 to silver and 0. And we notice there are 2 of the silvers, and that's partially because they needed those electrons from the copper. All right, so this is a redox reaction. I'll leave you to practice with the next practice questions, and have yourselves a great day.